Hi students, welcome to Akshar IIT Foundation and for the 6th class we are discussing about the chemistry in the topic water. So students, in the previous class already we started this topic and we completed introduction, different sources of water, and now we are going to discuss about the forms of water, right? So now see, here you know that water normally exists in liquid state. Students, did you know liquid? Yeah. So water normally exists in liquid state. Okay. Now if I take some water and if I place in the refrigerator for some time, then after some time, if I take out that water from refrigerator, what do you find? Good. You can find the ice. Means water is turned into the ice. So what do you find the difference? So difference here, initially it was liquid, but now it is solid, right? Now similarly, if you take the water and boil the water, then what happens? You can see that water is converting into water vapor. But what is water vapor? Water vapor is a gas. It is in the gaseous state, right? So students, water, based on the condition, it can exist in three states like solid, liquid, gas. Means ice, water and water vapor. So here you can see we are freezing the water, so it becomes a ice, and ice melts, again becomes a water. If you heat the water, water will be converted into the steam. Again if you condense the water, the steam will be converted into the water. So water can converted from one form to other form. Okay. So here you can see, so water in the nature exists in three forms. One is ice, second one is water, third one is water vapor. We can find the ice in the high peak of mountains like Himalayas, Arctic and Antarctic region in the form of snow and ice. So that is in solid state, alright. And normal water in the rivers and oceans and seas, we can find the water in the liquid state, right? And when you boil the water, water will be converted into the vapor, and you can see that even in atmosphere also water vapor is one of the component, right? So now let us see what are the properties of the solids, liquids and the gases. Okay, in three states, water only. So water formula is H2O, right? And water remains, its properties remain same, but the properties in the where it is changing in terms of physical, okay, in form of physical state. Based on the physical state, normally the matter is classified into solids, liquids and the gaseous state. So we have seen that water exists in three states, okay. One is ice, water and vapor. And as water is a matter, so we come to that matter exists in three states like solids, liquids and a gas. So when water changes into ice or vapor, there is no change in its composition or in chemical properties. So only there is a change in physical properties, right? Now what are those changes? What are the differences? Now let us see here. So here we discuss in the form of solids, liquids and gases. When first we see the mass. Actually the definition of mass is the quantity of matter. The quantity of matter. But now you are in the 6th class, so we can equate this mass with like weight, students. So weight. Now solids. So this is a solid. So solid has some definite mass. Okay, there is a particular mass. Definite means what? Particular. So here solids have definite, okay, definite mass, right? Liquids also matter. So matter has a mass, and here liquids also have the definite mass. Gases also a part of a matter, so they also have the definite mass. So definite mass. So all solids, liquids and gases have the particular mass. Very important point, students. Now, let us come to the volume. What is volume? The space occupied by a matter is called as a volume, right? Now, I want to know what is a volume, okay? So, for example, if I have here I have remote control, right? So, what is its volume? You know the formula of volume? Volume is nothing but a length into breadth into height. So, let this is a remote and this is a length. Let imagine this is a 15 centimeters and this is a breadth, and let think it is a 5 centimeters and this is a height. So, height is 2 centimeters. Now, 5 into 2 into 15. So, that comes to 150 cubic centimeters. So, the volume is 150 cubic centimeters. So, is there, so this is a particular volume. Now, if I press it, I am applying some force, okay. Does it volume changes? No, its volume does not change. The meaning is what? Solids have definite volume. So, solids have the definite, okay, definite volume, right. So, definite volume is there. What about the liquids? Liquids also have the definite volume, okay. How can you say? See, for example, your mama asks you to get the milk from the shop. Now, you go to the shop, right, and you ask for the milk. Then immediately shopkeeper, what do you ask him? So, he asks you how much milk you want, right. Then what do you say? I want 2 liters or 1 liter or a half liter. So, you are telling something, right. So, that liter represents the volume. That liter represents the volume. So, 1 liter, 2 liter, 3 liter. So, that represents the volume. Means liquids also have definite volume. So, they have the particular volume, right. Now, what about the gases? No, students. Gases do not have the particular volume because gases occupy the entire space available to them, right. For example, I am in this room and this room size is like 10 meter length, 5 meters breadth, 3 meters height. So, 10 into 5, 50 into 3, 150 cubic meters. Now, if I see everywhere in this room, there is air, means gases is there, right. Now, this total air, if I compress, if I collect and compress, then I can pack this total air of this room in one small container, yes. So, the meaning is what? Here the total air of this room, I can compress into the small box, okay. So, the meaning is what? There is no particular volume to the gases, right. So, they occupy the space available. So, no definite volume, right. Now, let us come to the shape. So, now solids have a definite shape. For example, you see here, this is particular shape, this is a cylindrical shape. Now, see the remote, this is a cuboid shape. So, they have the particular volume. So, there is a shape, there is particular shape exists for the solids. But what about the liquids? No. Liquids acquire the shape of the container. If you take the liquid, if you pour in the glass, then it acquires the shape of the glass. If you pour in the pot, it acquires the shape of the pot, right. So, there is no particular shape for the liquids, even gases also. If you blow the air in the balloon, then that gas is in the shape of balloon. If you blow the air in the box, then it is in the shape of box. So, the meaning is what? There is no particular shape for the liquids and the gases. Clear, students? Now, come to the intermolecular space. Now, the new word I am introducing. See a new word I am introducing to you, that is intermolecular space. Intermolecular space means, students, the distance between the two molecules. The distance between the two molecules. You know that any matter is made up of a tiny particle, small particles. In the solids, what happens? All the particles are very closely packed. How they are packed? Very closely packed. You can see, for example, this is a solid, you think. Here, closely packed like this. Okay. So, they are closely, all the molecules are closely packed. So, here they are closely packed. So, what is the distance between the two molecules? No distance, okay. So, very less. Intermolecular distance is very less. But in the liquid, what happens? See the liquid here, liquids will be like this. So here one molecule, here one molecule, here one molecule, here one molecule, like this. So now you see here the intermolecular distance, means the distance between the two molecules, means two particles, is little more. So here the little more intermolecular space between two molecules is little more. Now if you check about the gases, about the intermolecular space, so there is a lot of gap is there. If one molecule is present here, one molecule present there. Okay, so one molecule is present here, one molecule is present here, one molecule is present here. Like this, the gap between the gaseous molecules is very large. Okay, so lot of distance, lot of space between the two gaseous molecules. Now let's come to the last and final one, force of attraction. Do you know the attraction? The attraction, coming close. Okay, so the force of attraction between the molecules in the solid is very strong, very strong. That's what they are very close to each other. Okay, the force of attraction is very strong. So that's what they are very close to each other. And when you come to the liquids, the gap is little more. So the meaning is what? Force of attraction is less. Force of attraction is less. And what about the gases? There is no force of attraction. Okay, there is no force of attraction, or we can say the negligible. Okay, the force of attraction is negligible. We don't consider. So that is the force of attraction between the gaseous molecules. Okay, students. So these are the properties of solids, liquids, and gases. So very important, students. This actually you will be learning in your very higher classes like 9th or 10th classes. But here under part of IIT Foundation, we are explaining here. Is this clear to you? Okay, very good. So with this, we stop the class today, and note down this one, learn, try to understand perfectly, right? Bye students, take care.